So this is an RLC circuit with an AC source defined like so. We have 140 sine 500t. Notice an oscillation can be described with sine or cosine. In this case it is sine, and the syntax would be V0 sine in this case and omega t. So by identification, omega is 500, so we have access to omega, and therefore f, if we want to, f would be just omega over 2 pi. And if you do the math, what is it? Let's see, 500 divided by 628, which is almost 80. Let's put almost 80, so almost 80 hertz. Okay, the reason I'm doing this is to compare this to the resonance frequency. Alright, now we have here typical questions. What is the RMS voltage, the impedance, the RMS current, the RMS voltage across every component, the resonance frequency, and the power? These are typical questions you may expect. So the first one is, what is, let's use this one here, what is the RMS voltage? By definition, the RMS value is the peak value of a square root of 2. We recognize this is V0. This one is V0. So 140 divided by square root of 2 is 99 volt. That is the VRMS value of the applied voltage to the circuit. On average, 99 volt. Alright, that answers the first question. Second, what is the impedance for this circuit? The impedance, the name of the total impedance in the circuit is called Z. So it's kind of resistance mixed between real resistance of R and the stored and the energy stored and put back into the system by the C and L. The whole thing is called impedance, Z. So the definition of Z is this: XL minus XE squared plus R squared. This is one way to define Z. The other way is to take advantage of the triangle of the impedance. The Z is here for the total voltage. This is R. And so we can use trigonometry and figure out Z is R of cosine phi. And therefore R is given. It is here 1 kilowatt, which is 1000 ohms. If I find phi, then I have solved the problem. Or let's do it both ways. The first one, I need to define what is XL and XC. By definition, XL is omega L. We have omega 500, so it's much easier. And the XC is 1 over C omega. And R is just R, doesn't change, independent frequency. So R is given 1000. Omega L is 500 times 1 Henry is 500 ohms. The unit of reactance is also ohms, behaves like resistance. The XC is 1 over omega C, 500, and this is 1 micro. So all done is 2000 ohms. So these are the impedance, the reactance of every component. Now I can plug these numbers here and find what is Z. Well, Z is square root of XL minus XC. XL is 500 minus the XC is 2000 altogether squared, and plus the resistance squared, which is 1000 squared. All done, you are going to find almost 1800 ohms. Okay, this is one way to do it. The other way is to consider phi. Let's evaluate phi. probably I change the color. Phi is tangent -1. And now you don't have to remember this, memorize this. So XL minus XC over R. That's how you find the phase angle between the current in the circuit and the total voltage applied to the circuit. And so this is tangent. I have to rush a little bit because I have only 15 minutes and the system will stop. So XL is, we said it's 500 minus the XC, we said it's 2000 divided by R, which is 1000. Now all done. The angle is, obviously we expect negative because the system is mostly capacitive, 2000 ohms for C, and the angle I have 56 minus 56.3 degrees. Now I am find Z, which is R. You see, R, what is R? Is 1000 divided by cosine minus 56.3, and you are going to find almost the same thing, 1800 ohms. All right, so two ways to evaluate the total impedance. So let's answer this question here. Let's change the color now. This one. Determine the RMS current, where the RMS current, so this is 3, I, which is peak value, RMS value, is just the voltage, the RMS voltage, of course, the total, divided by the total impedance, which is Z. Now we have everything. So we said it's 99 divided by 1800, which is 55 milliamps. Number 4. Let's change the color. Let's use the red. Why not? Number 4. So we answer this one. This is 3. 4. So what we are going to do? Determine the RMS voltage drop across every component. So the V is always some kind of resistance, X times the current. And so for VR, it will be just the RMS value, which is 55 milli times 1000, which is R, and that is 50, what is this? 55. All right, that is the voltage across R. Then, so this is the VR. The VL, it is XL times the current. Well, XL is defined here somewhere. XL is 500, so that is 500 times the current, which is 55 milli. Of course, the RMS value. And you are going to find 27.5 volt. The last one is VC, which is also XC now times the current, which is XC is, we said, 2000 turn the current 55. Alright, and so this is equal to what is it, 110 volt. Now quick check. Now if you add all of them plus VC plus VR, you are going to find 192 volts, while the maximum value is 140. So we explained this in the lecture. These are vectors, so they don't obey simple arithmetic. That's why they don't add up to 140. We have to use Pythagorean theorem to do that. Okay, this is 192 volts. Okay, so we answer this question. What is the frequency of resonance? Well, just 1 over 2 pi square root of LC, and that is 159 hertz, almost 160 hertz. Notice this frequency is different from the frequency with which the system is oscillating. This is the natural frequency, the best selected frequency the system likes. So if you excite the system at this frequency, you take advantage of this component by producing the maximum current. So the frequency of resonance is 1 over 2 pi LC. So 1 almost 60 hertz. The last question is, what is the average power? Well, the power can be evaluated in two ways. Either I RMS squared times R. This is probably straightforward because we have the I, which is 55, 10 to the negative 3 squared, and we have R, which is equal to 1000. So this is just 1000. So all done, you are going to find 3, almost 0.3. Is it? Yes, 0.3. What? This is the power dissipated in R, because in C and L there is no power. The alternative is this: P RMS is I RMS V RMS. We have calculated this quantity, and then cosine phi, the power factor, and you end up with the same quantity. So I can do this: 55, 10, negative 3. Still have 2 minutes. And then the voltage is 99. We have calculated this earlier here. And then cosine, minus or plus, it doesn't matter. So I'm going to do 56 upon, what is it? 3. And you are going to find also 3.03 watt. Let's circle this one. Same thing. So we still have 1 minute. Now, these are typical questions: how to find the total impedance, how to find the phase angle, how to find the RMS values, recognize the syntax of an oscillation. Always max value, argument omega t. And the resonance frequency is different from the frequency with which the system is oscillating. And recognize also that the sum of the voltage, if they are added in simple arithmetic, they don't add up to the value of the voltage across the source. So I think with this you should be okay.